Hello guys, so let's talk about blockchain. If we go back to our blockchain warehouse example, we talked about stacked boxes. So stacked boxes are a blockchain. And then we said some boxes had some weight and this is a hash. And some warehouse workers are controlling this. They are checking that and this is a peer-to-peer network. Now, what is a blockchain now? It's like a database. So a blockchain is a decentralized database that everybody can look into. This is actually a blockchain. It is so the blocks are connected via some hashes, some previous hash, Merkle root, and so on. So this is how it's done. And miners are trying to find new blocks. And we use now some online tool. A tool to play around to check how blockchain works. And so with that, it's really easily to understand it. If you check out, we have here some blocks. So each of these boxes is a separate block. And they have a number to identify it. They have these nonce. This nonce was this value that the miner tries to find so he can add a new block. Then we have data. Data is a field for all the transactions, for example. Then we have the previous hash. This previous hash is actually the previous block, the hash of it. So in this example, in the first one, it's 0. It's all 0 because that's the first block. Then we have the hash, and the hash is actually the Merkle root. So this is generated out of the data, of the hashes from the data. And if we now, for example, change some data in between of those blocks, so in a block in the middle somewhere, if we change some data there, it's getting invalid. This block gets invalid, it's getting red, and all the blocks afterwards as well. The reason here is because we changed the data and all the other blocks are linked to it with the hashes, and the nonce is not correct anymore. So we have to find a new nonce for that. That's why we have to click on this mine button underneath. So if we click on mine, it starts to do the mining. So we are simulating mining, and then the block is getting green again. But this now means this block is correct and all the other ones afterwards are still invalid. We have to recalculate all the other blocks afterwards as well. And if we do that, then everything is green. So this means if somebody is doing a 51% attack, what we talked about, then he has to calculate all the blocks afterwards as well. So remine all of them if he wants to change something in between. So if a block is much more in the past, it's much harder to change this because you need a lot of computation power and so on. So some blocks in between are also really hard, but the last blocks are easier to modify. That's why some people say you have to wait 3 confirmations or 3 blocks until you can say that this block is really safe. And if we now spread this on multiple different nodes, so peers, then we have every of this peer has a separate blockchain. Like we see here in this example, everybody has his own blockchain and is verifying themselves, checking everything and so on. And if somebody breaks now something, in between something is invalid and they exchange this, they see immediately, no, it's wrong. They are all trustless. They are checking themselves first. They're checking and seeing, no, I have something else that's not right, you're wrong. And so that's how it's built up, and then changes are found immediately if somebody tries to make some changes. That's how it's working. So for you, it would be best if you try out this tool yourself, because that's the easiest way to understand how a blockchain works. So simply understanding that. And I give you the link here. You can check out, you can try to test, play around, play with this mining button to simulate mining. Try to switch on these tabs on top. There are different explanations. There are different things you can try out. Change some data, change the hashes, try around. And I hope you now understand a little bit better how blockchain works, what the blockchain is, and how nodes are working with them. Thanks.